Everybody say hi, Ashton. Hi, Ashton. All right. We are halfway through section 4.4. This is counting. This is permutations and combinations. We are to like step number 4, where we talked about permutations. So this one is underline some things here. Underline or circle. Items are identical. Items are identical. You will see problems like this. Actually, I'm just gonna do Allie. We're gonna do Ellie. We're gonna do Ellie's name because it's short, and we could do no Lily. I know, but she has 2 letters that repeat. I like that. What?
Mine is the shortest.
Yeah. Okay. Anyway,
Tie, actually.
we're gonna do Ellie's name. So here we go. Write out the words Ellie. This is Ellie's name here, and this is an example of what you'll see on your homework. Okay. Okay, she has a repeating E and a repeating L. Okay, so here's the deal. They're going to ask you if I take and separate these words and put them onto like little sticky notes or put them onto little pieces of paper and I put them in a hat. They want to know how many words or non-words, because some of them will be non-words, they won't make sense, that I can spell with the words Ellie. So let's say I pull out Lille. It kind of spells Lily, but with 2 E's, right? Right? Okay, so maybe I pull them out in that way. That is one combination, okay? Maybe I pull out a second combination that is IELEL. I don't know what that word is. That's a non-word, but it doesn't make sense. But that is another combination of words that I can pull out of this hat, okay? So here's the deal. The fact that Ellie has repeating letters, she has 2 letters that repeat in her name, even though her name is very short, it's only 5 letters long, but 2 of them repeat. That complicates things in the number of combinations that I could do. So I can successfully spell the name Ellie if I pull this one out first, this one out second, this one out third, this one out fourth, this one out fifth, right? If I pull them out exactly in that order, it will spell Ellie's name correctly, yeah? Yeah. Okay, but let's say I pull this one out first, this letter out second, this letter out third, this letter out fourth, this letter out fifth. Does it still spell Ellie? Yes, because I could switch those 2 L's around, right? I could also switch the E's around. So these 2 right here should not be treated as 2 different combinations because they still spell the same word, right? So that is something that's called repetition. Repitition. That's a lot of I's and a lot of T's. Repetition. And we need to use just a little bit different formula when we do that, okay? So normally when we're spelling the letters Ellie, if nobody has any repeating letters, like who doesn't have any repeating letters? Caleb doesn't have any repeating letters. Jackson, you don't have any repeating letters. Okay, a bunch of you guys don't have repeating letters. So if we're trying to figure out, like if Ellie did not repeat, she has 5 letters and we're trying to figure out how many combinations we could do. So how many letters could be chosen first would be 5 letters, then 4 letters, then 3 letters, then 2 letters, and 1 letter, right? That's the number of combinations. So it would be 5 factorial normally, except we have to divide out the repeats, right? The repeats go here, okay? Repeats, okay? Instead of like subtracting, is that what you're saying? Why do you divide them out? That's a good question. You divide them out instead of subtracting. I don't know. That's just what you do. I'm trying to think of why you just always divide them out. You divide out the repeats.
Why didn't we do that?
What? Because that was doing like two different categories. This is still the same. We're still talking about the same word. Okay, anyway, so we have to divide out the number of repeats. Ellie has 2 letters that repeat. Okay, and the first letter that repeats is an E, and it repeats twice. So we have to take 2 factorial. Okay? Times, she has a second letter that repeats. Listen. Is an L, and it repeats twice also. So we have to divide out another 2 factorial, okay? We would keep multiplying those if she had more letters that repeat. Like some people might have 3 letters that repeat. Some people might have 4 letters that repeat. There is 4 letters that repeat in the word Mississippi. So you would end up having 4 different numbers down below here, right? Okay, that you're dividing. So what we have to do is we have to divide those out. Now, if you're going to enter this into your calculator, you must make sure, unless your calculator does the fraction already, you need to make sure you put parentheses around this bottom part here. Or, to make things easier, let's look at it. You could divide by 1 and divide by the other. But let's think about this. What does 2 factorial mean? 2 times 1. And 2 factorial means 2 times 1. So you're really just taking 5 factorial and you're dividing by 4. If you want to do some of that in your head, it would be pretty good idea. You said 30. There are 30 different words or non-words that we can create from the word Ellie, right? Or from the letters of Ellie's name. There are 30 different ways of arranging them. And only 1 out of 30 is the probability of spelling Ellie exactly. Right? I have a 1 in 30 chance of pulling those out in the exact order to spell Ellie exactly. Does that make sense? Okay, I've divided out the repeating ones. There is only 1 out of 30 that is that exact combination. Otherwise, they're just non-words like these ones were. Okay, makes sense? Okay, so let's look at the formula that they've done up here. Can I move over?
Yes.
Okay, all right, here's the formula that they've done. N factorial, this is the total number. So in our case, we did 5 factorial because that was the total number of letters in Ellie's name. And then they did N1 factorial, N2 factorial, N3 factorial, all the way through for how many letters are repeating. So this was a 2 factorial times another 2 factorial. And then we would keep going if she had multiple letters repeat. But we only need to do those 2, okay? Keep in mind, put that in parentheses, all right? If your calculator does not do that already. All right, permutation rule with some identical items. Let's do this. When designing surveys, pollsters sometimes repeat a question to see if the subject is thoughtlessly providing answers to just finish quickly. Okay, this sounds like a question for Caleb. Okay, if I'm giving Caleb an opinion questionnaire and he's just going to go through and just like mark A, B, C, D, E, F, G, whatever, all the way through, right? So what I'll do is I'll take number 1, like question number 1 will be a question, and then I'll make that same question like question number 6 also. They'll say exactly the same thing, and I want to make sure that if he answers A for question 1, he also answers A for question 6, right? And that will tell me that he's not just answering randomly, right? Okay. So basically, it's a 10 question questionnaire, but there might only be like 6 different questions on it, right? But I'm repeating some of them just to make sure he's answering correctly. Okay. For one particular survey with 10 questions, N is 10. 10 questions. 2 of the questions are identical to each other, and 3 other questions are also identical to each other, right? So we have 2 identical questions and 3 identical questions, right? And those are going to be like the N1 and the N2. We have 2 of them that are repeating. We have 3 of them that are repeating. Okay, so we really only have like 5 different questions that are going on here, right? If I have 2 that are repeating and 3 that are repeating, I only have 5 different questions. For this survey, how many different arrangements can I make? So to calculate, we do 10 factorial on the top. And then we do 2 factorial times 3 factorial. If you want to enter that into your calculator, you can. Let's go ahead and let's look at what 2 factorial times 3 factorial is. So 2 times 1 times 3 times 2 times 1. Can you do that in your head? 3 times 2 is 6. 6 times 2 is 12. So you're basically taking 10 factorial and you're dividing by 12. Then you don't have to go back through and enter in those exclamation points every single time. That's helpful. What does that come out to be? 302,400. Still? Seriously? Woo! 302,400.
302,000. Oh my gosh.
That's a lot. That's still a lot of different ways that I can do that. Wow! 302,000. Is it practical to survey, this is the question right here, is it practical to survey enough subjects so that every different possible arrangement is used? I don't want to go survey 302,000 people. No. Too many people. I'm not going to use that many combinations. Too many people. I don't want to survey 302,000 people. Ugh, that sounds terrible. Maybe I don't even want to survey 2,000 people. I don't want to survey more than 20 people, but you know, whatever. Okay, there you go. Not too many, not practical. Go to the back side. Combination. What are some things that we know about combination? It has a C. This is NCR. Okay. What's true about C's versus P's?
It doesn't matter the order.
No order.
I wanted that.
No order. Okay. Combination. What's the word that we remember with combination? Caleb, what are you doing?
Sharpening my pencil.
Okay, committee. Really?
Brief intermission.
Brief intermission. Okay, write that down, NNR.
Is it short?
There you go.
Josh, pull your pocket knife out next time.
I was recording the other day and Jake Boniface was here and he went back to sharpen his pencil and he sharpens it and he's like taking forever. And he's like, oh, I just broke the tip of it off. So we had to start over again. I'm like, Jake! He did it on purpose, I'm sure. So anyway. All right, NCR, no order. You remember the word committee because committee starts with C and so does combination. Combination committee, C. Okay, in a committee, it doesn't matter what order you're called in. Doesn't matter. This is the formula for combination. We don't really care because you're going to use your calculator. You will never have to do this, even if you have it on the ACT. You will never have. I mean, most of you guys aren't taking the ACT anymore, but you will never have to remember that because you will always ever have your calculator for like the ACT stuff. So I don't make you memorize that formula. Okay. All right, moving on. In California's Fantasy 5 lottery game, what's up?
Do you know how to do a fraction?
I just do division. I use the division symbol. Help her, Kelsey. Okay. I'll come back and kind of help you here in a second. In California's Fantasy 5 lottery game, what is 5? In California's Fantasy 5 lottery game.
What?
Nothing, it doesn't matter.
5 is not like a relevant number thing in there. Don't get confused. They give you non-information. You can cross that out. Winning the jackpot requires that you select. Now this 5 is kind of important, I guess. 5 different numbers. You're choosing 5 from the numbers 1 to 39. How many numbers are there 1 to 39?
40.
There are actually 40 numbers if you include the 1, right? Right? If you include the 1, isn't there 40 numbers? Correct? Is it?
Yeah.
No.
No, it is 39 numbers. It's 40 if you include 0. Okay, 39 numbers. Woo!
India, I was doing the same.
And the same 5 numbers must be drawn in the lottery. I know you're counting. I'm thinking 0 to 39 because that would be 40 numbers. Okay, 39 numbers. The winning numbers can be drawn. Circle this in any order. So order doesn't matter. We have no order. It doesn't matter. Okay, how many different lottery tickets are possible? We have to figure out what N is and what R is. What is N? 39, not 40. Total number. R is the number that I'm choosing, which is 5. And we want to know how many different lottery tickets are available. So that's 39C5. If you try to type in 5C39, it will say no thank you. It won't say it that nicely, but it will say 0 or error. 575757. Okay, 575,757. Are you sure? Yeah? Okay. All right, find the probability of winning the jackpot when 1 ticket is purchased. 1 out of 575757. Good chances? Good chances?
Yeah.
No, No, I'm not going to go buy our lottery ticket. I don't think so. Nope. Nope. No. I mean, that's actually better. That's actually better odds than sometimes. I mean, whatever. But there also take into consideration that there's probably like 4 other people that are winning as well, right? You know, like maybe there could be 10 other people that are winning. All right, permutations or combinations, they don't tell you which one is which. We have to decide. So P or C, here we go. The Google company must appoint 3 corporate officers. They have the CEO, abbreviated as CEO, the executive chairperson, which is number 2. So we have number 1 person, number 2 person, and then the COO, which is the chief operating officer. That's the number 3. It must also appoint a planning committee with 3 different people. So we've got like 2 scenarios going on. There are 8 qualified candidates. Okay, so let's talk about the 8. What is the 8? The total number. Okay, R is the number that we're choosing. So even if I'm choosing the officer team or the committee, I'm choosing 3 of them. Okay, there are 8 qualified candidates, and officers can also serve on the planning committee, whatever. How many different ways can officers be appointed? Okay, so let's talk about officers down here. OFFICERS. If I choose officers, does it matter the order that I choose them? Yes, because they don't have the different position, or they don't have the same position. So in that case, I'm going to use a what? A P. So 8P, 3, and that is something. 336. Perfect. There's 336 different ways. Okay, now, B is the combination, right? This is the committee. Is this going to be more or less? Less. Why less?
Because the order doesn't matter.
Right? So why is it less? You're dividing out the repeating ones, right? So this is going to be less. 8C3 is going to be less than 8P3, and this is how many? What? 56 different ways? Okay? That's a lot less, right? Because you divided out the repeats, right? Okay, good? Questions about that? No? Okay? All right? Happy with that?
Yeah.
All right. Okay. The tricky part that you're gonna have is when they throw that repetition in there. So be careful of that. Okay? Yep, I'll go back. Yes. Yes.
Like a good one?
Yeah. Okay, everybody say bye, Ashton.